I think the topic today that was provided to me was Azure ML, right? So that's what initially I was talking about. But then, given the amount of time I had, so I initially thought of like, why can't I start this with the beginning of machine learning? Because a lot of people who want to get into machine learning or data science, like they struggle around to understand the fundamentals of machine learning. So this is going to be like a 10 minutes basics around machine learning to start with. But I think Akansha was generous and said, like, okay, if you have to go a little bit more than 10 minutes, feel free to do that. Thanks for that, Akansha. So, first of all, thanks to Global AI On Tour for providing me this opportunity to present this session. And of course, to our sponsors, Microsoft and R&D, like for sponsoring this particular event. So, we are presenting here from New Zealand, but it's good, right? Like it is across the world, and there will be a lot of sessions are happening, and you will get to see that. And all these sessions are recorded also. So, a little bit about myself. There is too much information on the slide, but I'm not going to talk about a lot of things. If you need to reach out to me post this particular session, feel free to reach out to me through my social media channels. And yes, of course, the slides will be shared post the session. Great. Straight away, we will get into the topic. So, I told about machine learning, right? So, what does really machine learning mean? Let us look at the real definition of that. Machine learning is a data science technique. This is going to allow computers to take existing data and forecast future behaviors or outcome trends. So this is what like a textbook definition is. But if I want to move this away, and if I want to say my history around how I started to get into machine learning, so I used to buy books. So this is what I like to do because I like to know about technologies. And so I normally jump on the book's website. So I go and search for a particular topic. So this can be like AI or Power BI and stuff. So look for a topic, search the book, and this book looks good. I purchased it, finished my transaction, and left it for a couple of weeks. And then I thought, oh, I finished this book, and someone recommended me to buy a different book around Power BI. So I jumped onto the same website, and then I searched for again Power BI. But while I was searching for Power BI, it automatically said like, oh, okay, I knew the book exactly what I was searching for. So I even put the book in there. But I saw a set of recommendations that came for me around other set of Power BI books. So I was astonished and said like, okay, I didn't ask for this. Why am I getting this type of recommendations? And how did they know like this is the type of books I'll be interested in? And that's when I started getting to know like, okay, so these are e-commerce websites. What they are trying to do is they want to understand about their customer behavior. So they look at the patterns of what the customer purchasing history is, and when they come back again, pretty much giving them recommendations around, yeah, last time when you came you looked for Power BI related books, and this time when you're coming here, these are some of the recommendations of books that you will be interested in. So it was a great customer service, and I was impressed like, okay, how did they really get into providing these recommendations? That's how my machine learning journey started, and I started involved to get to know more about machine learning. One of the common question that everyone has got it, what is the difference between artificial intelligence versus machine learning versus deep learning? So if you talk about it, sometimes this can be really overwhelming in terms of like, okay, how these definitions are really going to provide a clear explanation. So think about artificial intelligence. It's a overarching in terminology that I would say, which comprises of machine learning. And machine learning is again a subset of AI, which has got techniques where you can use your past or historical data to predict your future. And sometimes like a deep learning techniques are much more advanced or complex techniques. When you have really complex data sets or images or things that you have to deal with, you have to do use more deep learning algorithms. So deep learning is again a subset of machine learning, but mainly used for complex set of scenarios. So if you look at in that fashion, so you can clearly say deep learning is actually a subset of machine learning, and machine learning is actually a subset of artificial intelligence, which is the overarching buzzword everyone is talking about. So quickly moving on, we learned about what machine learning is, basically using historical data to predict the future. And how does a typical machine learning process look like? So is this going to be like a get the data and do some sort of apply some algorithm, create a model, and then the job is done because now the model is ready, people can use it? It's not the case. The journey starts with raw data, and the finally what you get is a model. So that is how the end-to-end process is. Start with raw data, finish it with a model. But what you have to do is the data doesn't is not going to be stagnant. So data is going to be always coming through into your organization, which means you have to keep on fine-tuning your model. So if you look at this process, raw data comes in, you'll be applying some sort of pre-processing, and which we call it as a data cleansing process. Because a lot of people, if you notice, I think if you have listened to Leila's session, she talked about data engineering, right? One of the key tasks around data engineering is about preparing the data so that you can use it for machine learning in your machine learning process. So cleansing comes as part of that. So you have to make sure like you cleanse the data, and then if there are duplicates, how do you handle about it? If there are empty values, how do you handle about those things? And then once you handle all those things, then you can just move on to the next step, is finding the right algorithm to solve the problem. So when you talk about machine learning, you are actually looking for a solution to solve a problem. And in the previous demo, you saw like, okay, what was the problem there? It was clearly said like if people have depression, and where do they go for? So that was in the previous session. I think Indra was mentioning. So that is the problem, right? And then she was showcasing like how can you use machine learning in order to solve that problem. So one of the thing is, once your data is ready, once you know what is the problem you're solving, then it is finding the right algorithm to solve that problem, which will help you to generate a model. And that model can be easily integrated with your downstream applications. So this is the end-to-end machine learning processes, and this has to be iterative process. So this is not a one-off process, you start and finish, because the data will be keep on coming through, and every time new data sets are coming through, your model needs to be evaluated to say whether it is still providing you the right accuracy or for your problem. If it is not, then you have to find out like whether you have to tweak the model, or do you need to choose a different algorithm because your pattern of data that is coming through is differing to what you had trained before. So machine learning process, as I said, it's an iterative process and it's not a one-off thing. So what are the different machine learning techniques that you have got? I think if you are new to machine learning, you would have heard a lot of people talking about supervised machine learning, unsupervised machine learning, reinforcement learning techniques, what they really mean. So if you take a supervised machine learning, I'm just explaining it in simple terms here. So here you will be starting to label the data. So you will be having a whole heap of data there. And first thing you will be doing is you will make sure like you label each and every data set, so that when you do predictions, it is going to use the labels in order to do the predictions. Simple example is like I had to build an application for my friend's daughter because she loves cats, and she had a whole heap of cat breeds that she wanted to know about. So what you can do is you can collect a whole heap of photos around the different breeds of the cat. You can label each and every photo saying what breed it belongs to, and then you can build a model and eventually use that model in an application. So which means every time when you upload a image of a cat, it can easily detect like what is the breed of the cat, and as well as provide more information about that breed. So definitely kids will love that type of applications. And the point I'm trying to make here is that is an example for supervised machine learning, where you are labeling the data, which means every image that you are uploading, you are going to label it to say like what breed it belongs to in this example. Unsupervised machine learning, here there is no concept of labeling here. Uh, a typical example is classifying things. So if you want to classify certain amount of data based on age groups or gender or something, in this case, like you are not going to label every single data set. The machine learning model itself will be learning through the data, and it will be applying those, creating those classifications for you. So that's unsupervised machine learning. And finally, reinforcement learning. Again, in simple terms, if I have to explain. So you are going to, every action it is performing, the model is going to perform, you are going to provide a feedback. So this feedback can be a positive or a negative, or it can be a neutral one. So based on the feedback, the model or the machine is going to learn and say like, okay, I got a positive feedback for the action I did, maybe that is correct. So next time when it is trying, depending on how you are giving the feedback, the machine is going to learn. And that's what reinforcement learning is really is. So you're not training it upfront, it is going to self-train based on the feedback you are going to give for the actions it is performing. So these are the key techniques that you need to understand when it comes to machine learning. So question is like, do I need to always use labeling in my data? If you can label it, well and good, because it will help in terms of improving the accuracy, but it is not mandatory. So if you can't label the data sets that you have got, that's where you have got unsupervised machine learning and reinforcement machine learning to compensate for that. So in this particular session, I wanted to touch upon machine learning tools. There are a lot of machine learning tools which you have got in the Microsoft stack. So if you look into the Azure stack, like we have got the Azure ML Designer, automated machine learning, and also the notebooks where you can go ahead and create your own machine learning models using different languages. So question is, if I'm a beginner, where do I start? So my recommendation is, if you are a beginner, understand the fundamentals of machine learning. So what machine learning is, the different techniques that I was explaining, and then jump on to using automated machine learning, because it will give you a feel around like how can I create machine learning models without writing a simple line of code. So one thing I wanted to talk about is the automated ML myths. So this is, people think about, if I use automated ML, does it mean I don't need data scientists in my organization, or there is no dependency on data scientists? Or does automated ML is used only to solve simple problems, not real world scenarios? I would say it's not the case. So you still need your data scientists in your organization. You're not going to get rid of them just because you're going to use automated machine learning. Why Microsoft has developed automated machine learning is, there are common problems across different industries. So when it comes to like recommendation models, right? So you can, this is consistent across a lot of e-commerce platforms. When you do price predictions, so if you want to predict a price of a car or price of any particular thing, or even what is the price of the petrol or energy or gas, anything that you want to do price predictions on, you don't need to create a different set of models, because the pattern is going to be the same, the data is going to be different, and then whatever output is basically is going to be a price prediction. So in those scenarios, like, you don't need to go and create different set of models or get your data scientists to do those things. So where there are common repetitive tasks that you want to use to create those models, that's where automated machine learning is going to be helpful for. So keep that in mind. If you're planning to use automated machine learning, it is mainly for like common problems that you can solve, but we are talking here about real world problems. We are not talking here about just a simple demo related problems. You can use automated machine learning happily in real world scenarios. So then when do I use automated ML? So as I said, when you have like a common problems that you can solve, then you need to first look for whether those type of problems can be solved with automated machine learning. So currently automated machine learning supports classification, type regression, and time series forecasting. So if I look at forecasting, forecasting is one of the thing which a lot of organizations use for, because they have to use the historical data to do demand forecasting, saying, okay, what are the things I need to do? My background working with the energy sector, they always plan ahead. So they will look for like the climatic conditions, and they have to plan saying, okay, in the next 7 days, if I want to generate electricity, how much I have to generate, how much I will be able to sell successfully in the market. So these type of scenarios, if you want to do, you can pretty much use automated machine learning. So the pattern here is, if your problem type which requires a solution of is of classification or regression or demand forecasting related one, then probably automated machine learning will be a good candidate. And again, you always, I said, like, you're not going to get rid of your data scientist. Whatever model automated machine learning is going to provide you, you can always look that model along with your data scientist to get their feedback, to see whether that is going to help your organization to achieve the better business outcomes. I think in our keynote today, they talked about responsible ML. So I'm not going to go deep into this, but just I wanted to highlight, when you're doing machine learning or creating machine learning models, keep responsible ML in mind, so that you have to be fairness around if you're proposing a solution for the problem using this. There are a few references I have got at the end of this talk. This will help you to get started with machine learning, what machine learning algorithms are, and how do I decide what is the right algorithm to use for the problem. If you are using automated machine learning, you don't need to worry about it. Azure will take care of it for that. But from a general knowledge perspective, so if you want to get a good basic knowledge, I would say go and refer these links and understand the fundamentals. So I'm happy to take any questions, and also just while we are showing here, I'll quickly show a simple the Azure Machine Learning Studio here and the model that was created using automated ML. This model was created using automated ML without writing a single line of code.